Hello, hi. Today we are going to discuss a chapter of vectors. You have heard about the word vectors. Vector is simply which is having a magnitude, and not only magnitude, and also it's having direction. Not only that one, it should obey vector algebra. So a vector means it should have a magnitude, it should have a direction, and it should obey a vector algebra. Such a physical quantity is known as a vector. Is it okay? Now listen here. Unit vector. Let me discuss the concept of unit vector. That's the first topic of this chapter. Before unit vector, you have to know uh, the representation of a vector. Normally, this is the vector. Listen here. This vector is starting from A and ending at B. Is it clear? So we can mark the direction of that vector is like this, vector AB. So length of AB is known as the magnitude of the vector. So direction is from A to B. So I can write the direction of the vector is from A to B, and magnitude of the vector can be denoted by AB vector magnitude, which is equal to length of AB. Is it clear? So it's a vector starting from A to B, and it will be having a length. That length is known as magnitude. Magnitude can be denoted by vector AB. B is equal to length of AB. Now we have to know what is unit vector. Listen here properly. Assume that the above vector, I am redrawing that one. Assume that the above vector is having a length of 10 units. Just assume. From A to B, I'm defining a vector whose length is equal to 10 units. You can see that direction is from A to B. Let me take a small part from this vector. A small part I'm taking, a small part. What is the speciality of that small part? That small part is also having a direction of A to B, the same direction. Is it clear? And I am taking the length of that small part as 1. So let me take that one as CD. So we can write that direction of CD vector is same as the direction of vector AB, right? So direction of CD is same as the direction of AB. Both direction is same. And also not only the direction, we can see that length or magnitude, of vector CD is equal to 1. So what is the speciality of that vector CD? So that's a small vector whose direction is same as the direction of vector AB. Not only that one, whose length is equal to 1 unit. Such a vector is known as a unit vector. A unit vector is a vector with the direction of the given vector and its magnitude is equal to 1. Okay. So generally speaking, listen here. So generally, A be the vector. We are representing a vector as vector A. A be the vector. And we know that modulus of A be the magnitude. Modulus of A be the magnitude or the length of that vector. And unit to vector, all of you listen here, unit to vector along the given vector A, along vector A is denoted by a cap. It read like a cap. So unit to vector along the vector A is denoted by a cap, where a cap is the vector along the direction of A whose magnitude is equal to 1. And also you have to remember a unit vector along a vector can be evaluated by dividing that vector by its magnitude. So listen, unit vector is equal to a vector divided by its magnitude. That is the concept of a unit vector. I hope it's clear for you. So unit vector a cap is equal to a vector divided by its modulus. Now we are discussing about the concept of I cap, J cap, and K cap. Listen here. Let me draw x-axis, y-axis, and z-axis. This is x-axis, and this is y-axis. This is z-axis. I hope it's clear for you. So let me take a unit vector along y-axis, a unit vector along y-x-axis, a unit vector along y-axis, a unit vector along z-axis. You can see I have marked one vector here along x-axis, direction of x-axis. Let me take this length is equal to 1 unit, this length is equal to 1 unit, this length is equal to 1 unit. So a unit vector along x-axis is denoted by I cap. So what is I cap? I cap is the unit vector along x-axis. It is a unit vector along x-axis. J cap is the unit vector along y-axis. J cap is a unit vector along y-axis, and the k cap is the unit vector along z-axis. So I cap is a unit vector along x-axis, J cap is a unit vector along y-axis, and k cap is the unit vector along z-axis. So this is J cap and this is k cap. So in simple words, all of you listen here. Assume we having a point here 1 comma 2 comma 3, so whose x coordinate is 1 as you know, y coordinate is 2 as you know, z coordinate is equal to 3. So let p be the point, p be the point. So that point p is having a position vector. We know that the position of p is 1 comma 2 comma 3. Let me discuss a new word, position vector. It's very easy. So if the position of P is 1 comma 2 comma 3, then position vector of P is I plus 2j plus 3k. It's very simple. With the first coordinate you give I, with the second coordinate you give j, with the third coordinate you can give what, k. So you are getting I plus 2j plus 3k. Another example I will give you. Assume we having a point minus 3 4 7, whose position vector, let me write position vector in short as PV. PV is equal to minus 3i plus 4j plus 7k. So this is the position vector of the point minus 347, which is given like minus 3i plus 4j plus 7k. So I think now if you're getting 1 point, you know how to write the position vector of any point. So in order to get the exact idea, let me give you one more example. Another example, assume that you're having a point 3 minus 2 1. What is the position vector? 3, so 3i, minus 2 minus 2j, 1, so plus. That is the position vector of that point. I hope it's clear for you. Now writing a vector AB, vector AB. Let us discuss the concept of vector AB. So we know that vector AB is a vector starting from the point A. A is having a coordinate of x1, y1, z1. And B is having a coordinate of x2, y2, z2. Okay, we know how to find the position vector of x1, y1, z1, and we know how to find the position vector of x2, y2, z2. So we're having a vector from A to B. So remember, vector from A to B is nothing but x2 minus x1 into I. What is that? X2 minus x1 into I, y2 minus y1 into j plus z2 minus z1 into k. So x2 minus x1 into I plus y2 minus y1 into j plus z2 minus z1 into k will be the vector from A to B. Let me give you an example for that. It's very easy. For example, assume you're having a vector. That vector, the initial point of that vector, let it be 2 comma 3 comma 4. It's A. and let it be the ending point 4 comma 5 comma 7. I need to write vector from a b vector is equal to, listen, x2 minus x1 4 minus 2 2i, y2 minus y1 5 minus 3 2j, z2 minus z1 7 minus 4 3k. So vector ab can be written as 2i plus 2j plus 3k. So far in this video we have discussed about what you mean by a vector, and what is the concept of a unit vector, and also how to denote a unit vector, and also what's the definition or what is the formula for finding unit vector along a vector. Then we discussed about, according to unit vector concept, we can divide a special types of unit vectors, which are I cap, j cap, k cap. I cap is a unit vector along x-axis, j cap is a unit vector along y-axis, k cap is a unit vector along z-axis. Now if you are getting a point in 3D, by giving I cap, j cap and k cap to that point, we can write the position vector of a point. So we did one example again for writing the position vector of a point. Now we learned how to write vector AB. A is an initial point, B is a terminal point. From A to B, we can define a vector. That AB vector can be written as x2 minus x1i, y2 minus y1j, z2 minus z1k. So example I wrote here, from A to B, I drew a vector. Vector AB 4 minus 2 2i, 5 minus 3 2j, 7 minus 4 3k. So in this video, we just discussed about the basics only. So we will continue with the other topics with the next video. Thank you.